Welcome to the video on analysis and design of a concrete beam. In this video, you will structurally analyze and design the concrete beam drawn in the previous video. Open the file of the previously drawn concrete beam. Now go to the Analyze menu. Click on Run Analysis. Here data and model are already defined, so click on Run Now. If the file is not saved before, it will ask you to save the file. Save with a relevant name. It's better to create a new folder. Save the file. The software now structurally analyzes the beam subjected to the loads and displays analysis results. Select Show Forces and Stresses. Select Frame, Cable, Tendons. The option for this, the options for different forces and stresses have been given in the drop-down list. Select Shear to 2. Click on Apply. The selected tab displays the shear force diagrams. Select the option Show Values. Click on Apply. The values of maximum and minimum shear force are displayed. Now select Fill Diagram and click on Apply. Option Moment 2 to 2. Click on Apply. Now select the option Moment 3 to 3. Click on Apply. Likewise, you can explore other options as well. Now right click on the beam. The software displays the 4 important analysis result diagram, that is the free body diagram, the shear diagram, the movement diagram and the deflection. It is showing the maximum shear value is negative of 28,997 kilonewtons and the maximum moment is 57.9947 kilonewton per meter. So considering the given beam, uniform load W equals to 5 kilonewton per meter and length L equal to 8 kilonewton. If you use these values in the formula, the maximum bending moment equal to 40 kilonewton meter and maximum shear force is 20 kilonewton. Maximum shear force is 20 kilonewton. The manually calculated values are not matched within the software. This is because when you normally calculate it, you are not considering the self weight of the beam. But when the but as the software considers the self-weight calculated from the properties of the beam. You can get the manually calculated values if you exclude the self-weight calculation from the beam. Click on Done. Go to the Define menu and select Load Patterns. You can see that all the options in the Load Patterns are inactive. This is because you have run analysis. So first go back and unlock the model. Click on OK to unlock the model. Now make changes to properties of your model. Now the options are activated as you can see. Change the value from 1 to 0 in self-led multiplier. Then click on Modify Load Pattern. The property of dead load pattern has changed. And now the software will not be considering the self-weight. You might be wondering the loads have been disappeared. Do not worry, the loads have not been deleted. You just have to select the relevant option to display the loads. In the display menu, go to Show Object Load Assigns and choose Frame. Select the load pattern name, which is dead in case, and then click on OK. The loads applied on the frame are now visible. Now analyze the frame again by selecting Run Analysis in the Analyze menu. Click on Run now and wait for the software to run analysis. Once the analysis is done, right-click on the beam to check the analysis results. But now the maximum shear is showing 20 and the maximum moment is 40 kilonewton meter. This is equal to the manually calculated values. Thus, you can see that the software accurately computes the analysis results of any model depending on the property set by you. Click on Done. But for actual analysis, you should not ignore the self-weight of the beam. So unlock the model, go to Load Patterns, of the model, go to Load Patterns in the Define menu, and rechange the self-weight multiplier to 0 to 1. Click on Modify Pattern. Click on OK. We will now run analysis. Click on Run now. In the Design menu, go to Concrete Frame Design. Select View or Revive. In the Design Code option, Select Indian IS 456 2000 from the top one list. Click on OK. Go to the design menu again. Start design or check off structure. Go to the concrete frame design. Start design or check. The software now designs the concrete beam. You can see that the longitudinal reinforcement area, three areas of the beam display. There is a color bar that shows different colors with some values. Okay. The values indicate the ratio of stress carried in the frame. Now go to design menu, concrete frame design. Verify all members passed. As you can see that all concrete members have been passed.